In today's lesson, we are going to be looking at the sine law. Now, this is going to be broken up into two parts. We're going to look at finding side lengths first and then finding angles in a future lesson. Again, this is a new concept. It is similar to some of the trig stuff we've learned, so this is going to be something that you want to practice. The reason we're breaking it up into two kind of different parts is because it can be a little bit tricky being something new. So again, make sure you're taking your time to learn this thoroughly and make sure you are practicing these concepts. So just a little bit of review. I want to label the following triangle. Right? The hypotenuse, opposite, and adjacent. Right? So I have my reference angle here. I have my 90-degree angle here in red, and then I have some side lengths or missing side indicated. But I don't need that to really, or I don't need those sides to really help label. I have my angles, which will help me. So across from 90 degrees is our hypotenuse. Across from our reference angle is our opposite. And then the side that's between the angle and our 90 degrees is our adjacent, or the last remaining side, or the side that's beside our reference angle. I want to do the same thing with this triangle. Label the hypotenuse, the opposite, and the adjacent. And if you're struggling a bit, that's okay, because we can't really label those three sides for this triangle. And the reason being, it's not a right angled triangle. Right? If we wanted to, we could determine what that last angle is. Right? This is 83 degrees. But none of these angles are right angles, so I don't have a hypotenuse. I don't have an opposite and adjacent. I have an opposite technically, but I don't know which would be the adjacent and which would be the hypotenuse because I don't have a right angle triangle. Right, so I can't label this with a hypotenuse, opposite, and adjacent. It's not a right angle. It's not a right angle triangle. So therefore, if it's not a right angle triangle, I can't use SOHCAHTOA or my right angled trig because I don't know what those sides are. So SOHCAHTOA can't be used for these triangles. And this is where the sine law comes into play. So when we're dealing with acute triangles, we can use sine law to help solve for missing sides and angles. And this is what the sine law looks like. Sine A over little a, sine B over little b, sine C over little c, or the reciprocals where everything is flipped and we have the sides on top and the sines on the bottom, or the angles on the bottom. Keep in mind, your capital letters represent angles and your lowercase letters represent sides. Now what the sine law is, it's basically a ratio between the sine of an angle and its corresponding side. And it's basically saying that that ratio is equal for every pair of angle and sides. So when we talk about sine law, we're going to be referring to pairs. And when we're referring to pairs, we're talking about something like this, where we have an angle and its corresponding side. So that's what we mean down here when in order to solve for a missing side, we need to have two angles and a side, or we say a full pair and half a pair. And now with sine law, it is going to be very similar when we're finding angles or sides. So don't worry too much about, well, do I have the right information? Do I have two sides and an angle? Focus on the full pair and a half pair, because that will be your key indicator of if you can use your sine law. Now we're only going to be dealing with two pairs at a time. So when we look at these formulas, we have three ratios or three pairs of angles and sides, which makes sense because we have a triangle. Now the only thing is though, we have two equal signs, right? Showing that these three pairs are equal. And we can't really solve an equation when we have two equal signs in an equation. It doesn't really work for what we're dealing with, right? So even though we're showing that all three sides or all three pairs are equal, we're only going to be dealing with two pairs at a time. So there's going to be a third pair where there's no information or I'm not using that information when we're trying to solve these problems. So let's work through an example. So I want to find my missing side length. And in this case, I'm going to be looking for this side here. So because I want to use sine law, I should have a full pair and half a pair. And if I look, I can see I have a full pair here. I have a side and an angle. And I have half a pair here. Let me use a different color for that one. Half a pair here, where I have an angle and no side, but I am looking for that side. So I have half a pair worth of information, so to speak. So this is where we can use our sine law. And we can see that our third pair, looking at the x, just draw it quickly here. This third pair here, there's no information there. I don't have that angle, although I could find it, but I don't have a side, which is okay because we're not going to use it. Because I'm not trying to solve for that angle or side. I'm trying to solve for z. So here we're going to write out our ratio or our sine law. So it's going to always be the ratio of an angle, or the sine of an angle, divided by the side length, equals another sine of a ratio of a sine of an angle divided by its side length. If you get confused with, well, this formula has z and y, and the formulas that you gave us earlier have a, b, and c, you can just erase these labels and relabel it as a, b, c if you prefer. Right? The labels are just different labels for triangles, different labels for the points. So it's the same idea. You can just change out what the points are, or what they're labeled as. Again, with some of the steps where we have the missing piece, or the side lengths on top, the lowercase letters, and the angles on top, again, it can be solved either way. Some people might prefer to have the side length on top when you're solving for it. Some people might rather just have one equation. That way you have less to worry about. It's up to you which you prefer. So I'm going to be using this formula, comparing the ratios of the side lengths or of the angles to the side lengths. I'm going to fill in my information. So sine of angle Z, or sine of 44, divided by side Z, which we don't know, is equal to sine of angle Y, which is 63, divided by the side length Y, which is 22. Now, in order to solve for z, I need to remove it from the denominator. I need to bring it up to the top. And we can get rid of that, or do that, and get rid of these fractions by cross-multiplying. So we're going to have 22 times sine 44 is equal to z times sine 63. Now, I want to get z by itself. I'm still trying to solve for that z. So I need to do something with sine 63. If we remember from our previous lessons looking at right-angled trig, right, sine of a value is just a value. So I can treat sine 63 as a number. So I can move it over to the other side. And when I move it over to the other side, it goes from multiplying on one side to dividing on the other. So 22 sine 44 divided by sine 63, which is equal to z. Now everything on the one side is just a calculation. So 22 sine 44 works out to 15.282 divided by sine 63, which is 0.891, rounded a bit. And if you do it this way, where you simplify it first before you divide, keep some decimal places. Don't round too early. If you're comfortable using your calculator, you can enter this all in at once or in one process, so you don't have to worry about rounding. But again, do what you are comfortable with. Maybe you go through and you do it step by step for the first little while, and then when you get comfortable with it, you can go through and do it all at once. But at the end, we should find that our angle, our missing side length is 17.2. So So it's a little bit longer of a step rather than our trig ratios, but it makes sense because we're dealing with a little bit more of a complicated triangle. Our next example, which is not A, it is B. Again, the same idea. We're looking for this missing indicated side length. So I need to use the pair of C. I need to use that pair for sure if I'm trying to find that side length. Now the only thing is, it's an empty pair. It's completely empty. I know nothing about this pair. I don't even have an angle. However, I do have two other angles in this triangle. So I can actually find this third angle by doing 180 minus 47 minus 84, which gives me an angle of 49 degrees. So I now have half a pair for this, for the side that I'm looking for, which is what I want. And I have a full pair by looking at angle B and side B, because I have an angle and I have a side. So now I can set up my ratios. Here I have A, B, and C, so it kind of works with the formulas that we were given. So sine, and I'm going to switch it up this time. I'm going to put the full pair on the left side, just to show you that it doesn't really matter which way we do it. Sine C over little c. We have sine of 84 over 106, which is equal to sine of 49 over c. Our first step is going to be cross multiply. We want to get rid of these fractions, bring the c up. So we have c times sine 84 is equal to 106 times sine 49. I want to get c by itself, so I have to move the sine 84 over, and it becomes division. So 106 times sine 49 divided by sine 84. C is equal to, or I'll simplify it first. So on top we have 79.999. This one you probably could have rounded to 80, but I want to keep it consistent by not rounding too much. And then sine 84 works out to 0.995. And when I divide those two, I get a side length of 80.4. So again, similar steps to the previous one, right? Kind of, and again, it's going to be more of a, this one is going to be practice, right? Similar to how we practice the same three methods for the right angle trig. It's very similar here, right? You become more comfortable solving these types of questions, going through this process when you practice it, right? So it's going to be the same kind of steps: cross multiply, isolate for one of your variables, and then calculate. So looking at a word problem, an architect designed a house that has a 12 meters wide. The rafters that hold up the roof are equal in length and meet at an angle of 70 degrees, as shown at the right, or below. The rafters extend 0.3 meters beyond the supporting wall. How long are the rafters? This one's going to take a little bit of prior knowledge, but I'm going to just draw the triangle separately off here without kind of all the I guess creative parts of it, just so we kind of have the bare bones. So we have 70 and we have 12 meters. And we're looking for the length of one of the rafters. I'm not going to worry about the 0.3 because that is this little extension off at the end, right? So whatever I find for X, I'm going to add 0.3 to it. So I'm not worried about that portion right now. Right? I'm only focusing on this part of the house. Now, I'm going to use sine law, right? It's the sine law note. The other way we can think of it, it's not a right angle triangle. I can see I have a full pair here, but for this side, I'm missing some information, right? I have an empty pair. I don't have half a pair. So how can I find the angle? Well, if the rafters are equal in length, that means that these two sides are equal. So if these two sides are equal, it's an isosceles triangle. And if it's an isosceles triangle, then these two angles down here are also equal. And if we know what one angle is, I can subtract it from 180 and get 110, and then take that and divide it by 2 to split it up evenly between the two angles and get 55 degrees. So now we have enough information to go through and find this missing side length. So it did require a little bit of prior knowledge, but we got enough information to go through and use our sine law. Now we don't have any letters A, B, or C. I'm just going to use A and B. So sine A over little a equals sine B over little b. Again, labeling it doesn't really matter so much because as long as you keep your pairs together. So I'm going to have sine of 55 over x is equal to sine of 70 over 12. I'm going to cross multiply and get 12 times sine 55 equals x times sine 70. I want to get x by itself, so I'm going to move sine 70 over. We get 12 times sine 55 divided by sine 70 equals x. Oops, 2 equal signs equals x. Kind of going off to the side here. So bring it kind of back over. Again, this just becomes one calculation. I'm going to do it again step by step. You don't have to if you're comfortable with your calculator. 9.8 to do 9.8, just one more extra decimal place here, divided by sine of 70 is 0.9397 equals x. So I have when I go through and then simplify this further, we get a value of, that doesn't make sense, 12 times sine 55 divided by sine 70. There we go. So we get 10.46. We'll say 10.5. So 10.5 is my value for x. Right? However, I want to know how long the rafters are. The rafters also have that 0.3 meters extension beyond the edge of the building. So the rafter length is actually going to be 10.5 plus 0.3, which is equal to 10.8. So we have 10.5 meters from the peak or the top of the house all the way down to where it goes off the edge of the house. So we just add those two together, we get 10.5 or 10.8. So the length of the rafter is 10.8. Next example, so Scott is a naturalist. He is studying the effects of acid rain on fish populations in different lakes. As part of his research, he needs to know the length of Lake Lebarge. Scott makes the measurement shown. How long is the lake? So this is what some surveyors do sometimes when we're trying to measure the lengths or the height of objects, right? If it's too big, we can kind of use, or we can't travel across it, we can use angles and some lengths to help us figure out these different measurements or these different distances. So we have the lake. We want to find how long the lake is. So we are looking for this side length here. We'll call this little c. That's what we're looking for. So again, if I look at this triangle, I know I'm going to have one pair here. I know I'm going to be using sine law because it's not a right angle triangle, and sine law is the only law that I know right now for non-right angle triangles. But I'm missing a full pair. I can see one other side length, so it probably makes sense that I am going to be dealing with this side. However, I don't have the angle, but very similar to the previous one. I can do 180 minus 48 minus 52 because we have all of those, because we have our two other angles. And we're left with an angle of 80 degrees. So this angle down here is 80 degrees. And now I have enough information. Right, I have my full pair and a half pair. I do have labels for A, B, and C, so I can say sine A over little a equals sine B over little b. Again, whether you put A on the one side, B on the other, or the side lengths on top and the angles on the bottom, it's all going to work out in a similar manner. I'm going to fill in my information. So sine of 80 divided by 4,340 is equal to sine of 48 divided by c. I want to bring c up, so I'm going to cross multiply. And have c sine 80 equals 4,340 sine 48. Get c by itself by bringing the sine 80 over. It becomes division. C equals 4,340 times sine 48 divided by sine 80. Again, I'll simplify this piece by piece. So 4,340 times sine 48. We get 3,225.25 divided by sine 80, which is 0.9848. And we divide the two. We get 3,275.00. So say 3,275, which will be our final answer. So that is how long the lake is. So again, new concept, new formula, right? But once we plug in the values, as long as we recognize that sine of a value sine of a number is just a value, this is very similar to solving some of the proportions that we've done before, right? Very similar to the similar triangles that we did earlier in this unit. Very similar to solving proportions or unit rates back in grade 9. Right now, instead of just using all values, we have angles and we're using sine, the sine ratio within this, or the sine formula within this. So again, make sure you're practicing. It is a new concept. Make sure you're going through these steps, right? The more you practice, the more you become familiar with these steps, the easier it becomes.